So this is lesson 3.2a, college algebra, and one of the things about this chapter is that each of the lessons is a little bit shorter than in chapter 2, so hopefully it won't take like 4 million videos to get through this stuff. But this is going to be the beginning, I guess, of some really new stuff. And what we're going to do is we're going to learn how to graph polynomial functions. And the way to graph these can be a little bit long, not really hard, but a little bit long, and there's a lot of theory involved here on understanding what's going on in these graphs. So try to keep it short and simple, but I don't want to miss anything either. So graphing polynomial functions. All right, so if we have a polynomial function, let's call it p of x, and it has an equation that looks like this. Sorry, it's early and my brain isn't really working real quick. And I've got something like that. Alright, so just looking at that gives me a little bit of information. It tells me how many zeros there are, okay, how many times it crosses the x-axis, how many answers there are. And if I take this biggest number here and I subtract 1, it tells me the most number of turning points this graph has. So basically what it's saying is turns there once, turns there once, turns there once. So notice it turns 1, 2, 3. It doesn't have to turn 3 times, but at most it will turn 3 times. Okay, usually it will turn 3 times because again, this tells you how many times it crosses the x. 1, 2, 3, 4. So that means if it crosses here, in order for it to get to cross it again, it's going to have to turn. And then after it crosses that, in order to cross again, it's got to turn around again. So it's going to turn around one less than the highest number here. Okay, so that's pretty much what that box on the bottom of page 270 says. So let's go ahead and look at this as far as graphing it. Okay, so the first step when we graph these, and there is a list of steps on the bottom of page 272 that would be good for you to get down in your notes. So let's go ahead and look at this. If you look at the very first step, that means you're going to look back on page 258 and determine what, well, let me get back there to 258 here. You're going to determine what the end behavior looks like. So it gives me as my end behavior for this something that looks like this. So again, I don't know what goes on in there, and this time I do care. That's one of the things that I'm going to be doing, is finding out what goes on in between here. But I know at both ends it's going to go down into infinity. Okay, so my range is going to go from whatever numbers the max we have up here is down to infinity. It's going to go right to infinity and left to infinity. So I know those are my end behaviors. So that's all we're going to look at as far as that goes. All right, the second part that we're going to do is find out what the zeros are. We're going to try to figure out where this graph crosses the x-axis. So in order to do that, we have to find out what x is if y is 0. Because if y is 0, then it obviously is crossing the x-axis. So 0 equals, and let's factor out an x squared, no, an x, I can factor out an x cubed. In fact, I get that. Okay. I can either leave it like that, or I could factor out this negative as well. Let's just leave it right there. So x cubed equals 0, or negative 2x plus 3 equals 0. So let's go ahead and solve this. So there are the 2 points, where it crosses the x-axis. Okay? Just something to bring up here. Because this has a 3 on it, we get the answer 0 3 different times. Okay? So this tells you that our answer is 0, yes. In fact, we get x equals 0, but we got it 3 times. So we do have 4 answers to our problem, 3 zeros and a 3 halves. So what does this tell me? It tells me that my multiplicity over here, my multiplicity of 0 is 3, and my multiplicity over here, since there is only one answer here, is 1. Okay? So my x-intercepts are 0, 0, and 0, oops, sorry about that, 3 halves, 0. Okay, so that's where it crosses. So I found more information here. So I found the shape, and I found where it crosses. Alright, so let's get some of this out of here. Okay. So, what did I say we got? We got 0, 0, and 0. Whoops, gosh, I keep doing that. 3 halves, 0 as my zeros of the equation, or where it crosses. So, on a graph, what that means is I have 3 different what are called intervals here. I've got it crossing at 0, and I've got it crossing at 1.5 or 3 halves. So there. So that's 3 halves. So I've got things that are going on from here over here, from here to here, and from here into infinity. So I have 3 different intervals. So what I have here is 3 things that I need to determine what's going on. Alright, so what I do is write down my intervals. So one of my intervals is negative infinity 0. So that's everything that goes on over here. I've got 0 to 3 halves, which is everything that goes on in here. And then I've got 3 halves to positive infinity, which is everything that goes on over there. Okay, so those are my 3 intervals that I want to look at. Alright, so let's say that I want to know what in the world is going on at each of these intervals. Alright, so what I'm going to do is I am going to make a little table here, so I'm going to have to get rid of some stuff, and I'm going to rewrite these intervals here up here at the top in just a second. Okay, so there's my 3 intervals I have again. Now see, notice my intervals are 1 less than this here. So what happens is this is going to do something. We're going to change direction and worry about this, and we're going to change direction and worry about that. Alright, so what we're going to do is we just grab a number in here, somewhere between 0 and negative infinity, and see what happens to it. So the book picks -1. So we're going to take a -1 and put it in. So when we find a number somewhere in here, we're going to plug it into here and see where our y value is, see where that point is. So let's go p of x. So when we put -1 in, well, actually this should be, yeah, let's leave it p of x. So let's put -1 in. When we put -1 in, it spits out a -5. When we take a number between 0 and 3 halves, let's take 1, it's going to kick out, when we put it in this equation here, it's going to kick out a 1. And then we're going to pick out a number between 3 halves and infinity, so let's pick 2. Trying to pick numbers that are small, and it kicks out a -8, and that are easy to stick in this problem here to see what our y values are. Alright, so there we go. So, what is the sign of p of x? Sign there would be negative, sign here is positive, sign here is negative. Okay, that's a key thing. That's what we're looking for. I don't care necessarily what these y value answers are. I just want to know if they're negative or positive. That's all I was doing by plugging a number here in for here, is just to find out if my y value was below the x-axis or above the x-axis. That's all I care about. Okay, so now what I have is I have a graph, and I don't want to get ahead of myself. Okay, so there's my graph, and I know that at, do this in red here, 0 and at 3/2. Okay, I know that over here, from negative infinity to 0, we're below the x-axis. That's what that sign means. Between 0 and 3/2, the sign's positive, so I know here we're above the x-axis. And I know from 3/2 to infinity, the sign is negative. So we are below the x-axis. So remember, before we gave the end, what's happening on the end, it's going to look like that. And that kind of makes sense. If we take this and put it over here, from here over this way, we're going to be going down. And over here, we're going to be going down. And we don't know what in the world we're going to be doing up here necessarily yet. Alright, so now let's say we want to find out where our graph crosses this y-axis. Alright, so remember, to determine where it crosses the y-axis, what is the x? The x is a 0, so it's 0 some number, and that'll cross the y-axis. So let's take our original equation. Whoops, I've got to remember to put a 0 there. We're going to put a 0 in for x. Okay, so it crosses the y-axis at 0. P of 0 equals 0. So that's another one of my points. 0, 0. Okay, so that works for me. So this is where it crosses the y-axis. Alright, so a few additional points, because we're really not sure what is going on here to here. We know that here it's going to go down and here it's going to go down because that's what the end behavior says. But we don't know what's going on in here. I mean, this thing could go like that for all we know. So we're going to put some points in there and figure out what we get. And that's what the book does. Step 5 on page 272 is it puts in a bunch of points. And then when it draws the graph, it gets something like this. Okay, so it goes up, crosses once. Okay, my drawing is not real accurate because it goes up. Okay, it does not go back down below. It crosses here and stays above the line, because that's what this plus means. Between here and here, it stays above the line, and then it goes back negative down here, because that's what this says it does. Once we go to 3/2 infinity, we're below the line, so it has to cross and go back down at 3/2. So by putting some points in here, and that's the thing you're going to do, you're going to look at this interval here that you don't know what's going on, and you put 3 or 4 points in here, and you'll find out it kind of does weird things here. Okay, and that ends up being what you've got. So we have a degree of 4, so that means we have at most 4 places it crosses, and in this case it crossed 2. Basically 3 times at 0 because it was x cubed, so it goes through here, pop, 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 multiplicity of 3, then continues up, then crosses that. So that's it for section 3.2a. We'll continue with 3.2b.